Prestressed concrete. The term prestressing means the deliberate creation of permanent stresses in a structure before it is subjected to any imposed load. Because the object of prestressing a structure is to improve its performance, the stresses resulting from prestressing are designed to counteract those induced by the active loads. As you know, concrete is very strong in compression and weak in tension. Therefore, a simply supported plain unreinforced concrete beam subjected to an increased load will fail immediately after the development of cracks. However, by providing suitable steel reinforcement to the same beam can result higher load carrying capacity. As opposed to reinforced concrete, where the concrete is allowed to crack under service load, the original development of prestressed concrete was based on the prevention of flexural cracks forming under service loads. This was achieved by applying the criterion of no tensile stresses because it is generally accepted that if there is no tensile stress present in the concrete, it will not crack. However, the design will depend on the requirement and the designer's choice. With the subsequent development of the concept of partial prestressing, significant tension and controlled cracking are allowed to develop at service load levels, in much the same way as in reinforced concrete. In prestressed concrete, the most commonly used method of applying the prestressing force to the concrete is by tensioning high strength reinforcement, commonly referred to as tendons, against concrete prior to the application of imposed load. Two different processes can be distinguished in this regard. Pretensioning. In pretensioning, the prestressed reinforcement is tensioned before the concrete is placed. The other method is post-tensioning. In post-tensioning, the prestressed reinforcement is tensioned after concrete has been placed and has developed sufficient strength to sustain the induced stresses. An important difference between pretension and post-tension system is that it is easy to incorporate curved tendons in post-tension systems. The flexible duct can be held to a curved shape while the concrete is poured around them. One advantage of post-tensioning over pretensioning is that the tensioning can be carried out in stages, for all tendons in a member or for some of them. This can be useful where the load is applied in well-defined stages. Let's move to the details. Pretensioning. In pretensioning, the form of wires or strands are tensioned between anchorages and the concrete members cast around the tendons. Once the concrete has hardened sufficiently, the anchorages are released and the prestressed force is transferred to the concrete through the bond between the steel and concrete. The tendons are then cut away to produce the finished concrete member. A typical pretension beam design is given here. Let's move to post-tensioning. The prestressed force is applied in this case by jacking steel tendons against an already cast concrete member. Nearly all in situ prestressing is carried out using this method. The tendons are threaded through ducts cast into concrete or, in some cases, pass outside the concrete sections. Once the tendons have been tensioned to their full force, the jacking force is transferred to the concrete through special built-in anchorages. A typical post-tension beam detail is shown here. Let's see some typical components in pre-stressing. A strand consists of several number of wires. Cable or wire rope got several number of strands. Ducts are used in post-tensioning. It protects the strand. Here you can see anchorage blocks used in some post-tensioning systems. The wedge also useful in prestressed concrete. Equipment such as stressing jack, strand threading machine, strand cutter, and grout mixture and pumps are shown here.